Hi viewers, today we are going to see probability ICSE grade 10. So if a coin is tossed, two possible outcomes are head or tail. It's not actually two coins, one coin. It can either give head or a tail. A single coin is tossed. These are the two possible options, head or tail. So question 1 is, a coin is tossed once, find the probability of getting a tail, and B is probability of getting not a tail. So if you see the sample space, that's a possible outcome. So it can be head or tail. Let A be an event of getting a tail. That's going to be one outcome. So N of A is 1. Number of events is 1. And number of sample spaces 2. N of S is 2. So probability of getting a tail equal to N of A by N of S, 1 by 2. Probability of not getting tail is the second part of question. So probability of getting tail plus probability of not getting tail is equal to 1. So total possible outcomes, you sum up, the probability is always 1. So we already know probability of getting tail is 1 by 2. So probability of not getting tail is going to be 1 minus 1 by 2. So take a LCM, 2 minus 1, that's going to be 1 by 2. Next question 2. A bag contains 3 white balls, 5 black balls and 2 red balls. So and we need to find the probability of getting black, red and white as 3 set of questions. So the total possible outcomes, N of S or sample space or total possible outcomes, however you say, it's the same. That's going to be 5 black balls, 2 red balls and 3 white balls. That's equal to 10. So N of probability of getting a black ball is equal to, there are 5 black balls, so 5 by 10. Further simplifying, it becomes 1 by 2. Next, probability of getting a red ball equal to, red is 2, so 2 by total outcomes is 10. Further simplifying, it becomes 1 by 5. Next, probability of getting a white ball. So there are 3 white balls, so that's going to be 3 by total outcomes is 10, 3 by 10. There are 2 more part of the question. D is not a red ball. So 2 red balls are there. We can exclude those 2. So 5 plus 3 is 8. Probability of getting not a red ball. That's going to be 8 by 5 plus 3 is 8 by 10. Further simplifying, it becomes 4 by 5. Next is probability of not a black ball. So probability of getting not a black ball, we need to exclude count of black here, that's 5. So 2 plus 3, that's going to be 5 by 10. That is simplifying 1 by 2. So next question is, in a single throw of a die, we need to find the probability of different things. So if you throw a die, you can get either 1, 2, 3, 4, 5 or 6. These are the 6 possible outcomes. So greater than 4 means 5 and 6. Less than or equal to 4, you can include 4. And for the third option, not greater than 4. So we'll find it one by one. Possible outcomes or the total sample space That's going to be 1, 2, 3, 4, 5, and 6. So the total number is 6 possible outcomes. N of N of s is 6. Now probability of getting a greater than 4 is, it can be only 2, 5 or 6. That's going to be 5 or 6. So it's going to be 2 by total outcomes, 6 possible outcomes. So further simplifying, it becomes 1 by 3. Next, probability of getting less than or equal to 4, wherein we need to include 4 also. So 1, 2, 3, 4. There are 4 possible numbers, 4 events possible. So 4 by total possible outcomes is 6. That becomes 2 by 3. Next is probability of not greater than 4. So again, it's only 4 numbers, 1, 2, 3, and 4. That is 4 by 6, 2 by 3. Next question, in a single throw of dice, find the probability of getting even, will not be even, and will be odd, or the 3 parts of question 4. So first, possible outcomes when you throw a single die is going to be 6. 1, 2, 3, 4, 5, 6. Next, if you see what will be the probability of getting even is the first part of the question. So probability of even numbers, if you see, that's going to be 2, 4, and 6. So probability of getting even number is 3 by 6. Further simplifying, 1 by 2. Next, probability of not an even is, exclude these 3. So the remaining 3, 1, 3, and 5. So again, 3 by 6, 1 by 2. Next, probability of getting an odd number is again 1, 3, and 5. So that's going to be 3 by 6. Further simplifying, 1 by 2. So in the next question, from a well-shuffled deck of 52 cards, we need to find different probabilities. So we know the cards have 18, clover or clubs, diamond, and spades. And each one have ace, king, queen, jack, and numbers from 2 to 10. That's 9 numbers. So if you see the total count, it's each one is 13. 4 plus 9, 13. And it is 4 times if you do for 4 different colors. So 4 different cards, it's going to be 52. Of which you know art and diamond were reds, clover and spade were blacks. So this much if you know, we can solve this probability. First, we will see the total possible outcomes, or it can be the sample space. That's going to be 52. That's the total. 52 decked. So 52 cards. Next, we need to find the probability of getting a black card. So probability of getting cards in black or black cards, that's going to be clover and spade together. So 13 2 times, that is 26. So that is the 26 by 52, which on further simplifying you get 1 by 2. Next part of question is probability of not a red card. So that again clearly shows excluding the red cards. It's again those two blacks, clover and spade. 26 by 52, again 1 by 2. Third part of the question is be a red card. So probability of getting a red cards, so that is 13 diamond and 13 artines together, that makes 13 2 times, 26 by 52, further simplifying 1 by 2. Next, probability of getting a face card. So the face card, probability of getting a face card, Here the face cards are 4 king, 4 queen, 4 jacks. So that's going to be 4 3 times 12. So 12 by total outcomes is 52. Further simplifying, 3 by 13. Next, probability of getting red face cards. So that's again king, queen and jack, but only for the reds. So 2 kings, 2 queen, 2 jacks. That's going to be because for the red, and it comes up to total 6. So 6 by 52, which is on further simplifying, you get 3 by 26. So next question, if A and B are the two complementary events, then what is the relationship between P of A and P of B? So for the basic thing we need to know for probability is sum of probabilities of all possible outcomes is equal to 1. So this is very important to remember. So you sum up all the possible probability, sum of all probabilities of all possible outcomes is 1. So probability of A plus probability of B is equal to 1 is the relationship. Here I'm showing the reference of question 2. We had 5 black balls, 2 red balls and 3 white balls. So the total is 10. 5 plus 2 plus 3 is 10. And if you want to say for black balls, it becomes 5 by 10. For red, 2 by 10. For white, it's 3 by 10. When you sum up all those 5 plus 2 plus 3, because it's a like fraction, the denominator is same, it becomes 10 by 10, 1. So that is what we are trying to prove here. Sum of all probabilities is equal to 1. So second part of the question is, if probability of happening of A is 0.46, what is the probability of not happening of an event? Probability of A plus probability of B is 1. So we already know the probability of A is 0.46. So not happening is same as probability of B. So probability of B equal to 1 minus 0.46. That becomes 0.54. So probability of not happening A is same as probability of B. Next question, in a table tennis match between Geeta and Ritu, probability of winning of Rita is 0.73. We need to find two different probabilities. Probability of winning of Geeta we need to find. So winning of Geeta is complementary to winning of Ritu, and winning of Ritu is already given. So probability of winning of Ritu is given in the question itself. It's 0.73. So probability of winning of Geeta plus probability of winning of Ritu is 1. Probability of winning of Ritu is equal to 1. So we can find the probability of Geeta as Ritu's is already given in the question. So probability of winning of Geeta is equal to 1 minus 0.73. That's 0.27. Next, not winning, we need to find 4. So probability of winning of Ritu plus probability of not winning is again going to be 1. So probability of not winning, that's going to be for Ritu is 1 minus 0.73. So it's 0.27. So next question, in a race between Mahesh and John, the probability of John losing the race is 0.54. So we need to find the probability of winning of Ramesh and winning of John. These are the two parts of question 8. So probability of John losing is already given. The same as probability of Mahesh winning. So that is the answer for the first part of the question. So probability of Mahesh winning is 0.54. Next, probability of John winning plus probability of Mahesh winning is equal to 1. We already know Mahesh winning probability. So winning probability of John is equal to 1 minus 0.54. That's going to be 0.46. Next, find the probability of a sure event. And that's the first part. Let's do the first part. So in a sure event, N of E is equal to N of S. Event is same as total number of sample space. So probability of sample space is N of E by N of S. That is 1. Both are same for the sure event. Number of N of E here is number of elements in an event. E is same as number of elements in sample space. I'm just expanding the abbreviations here. Second part, find the probability of an event when impossible. So that's the second part of question. So probability of S is 0. Since you know A is an event which has no elements in the sample space. So N of E is 0 actually. 0 by N of S is, it's not there in the list of sample space, so it's 0. Third part of the question we'll solve. Probability of the event always lies between 0 and 1. So that is 0 less than or equal to P of E less than or equal to 1. So let S be the sample space and E be the events. So we need to find this is same. So 0 less than number of elements of event E is less than the number of sample space by dividing by number of sample space. This proves the probability of event lies between 0 and 1. So number of elements in an event E cannot be less than 0, that is negative integers, or even greater than 1, greater than number of in the sample space S. Next question, if a die is thrown, find the probability of getting 5, 8, less than 8 prime number. So first is, we know when a single die is thrown and probability of getting 5 is only 1 out of 6. Sample space is 6. 1, 2, 3, 4, 5, 6. So n of s is 6. So probability of getting 5 is equal to n of e by n of s. So that is 1 by 6. Next, third part of the question, probability of getting less than 8. So all 6 are favorable outcomes for this. So probability of getting less than 8 is 6 by 6 and it's 1. Next, second I missed, that is probability of getting 8, which is not possible because it's not available in the sample space itself. So that's going to be 0 actually. So probability of getting a number 8 is not possible. So 0 by 6 is 0. Next, probability of getting a prime number. So of the 6 outcomes, prime numbers are 2, 3 and 5. So 3. So probability of getting prime number is 3 by 6. Further simplifying, 1 by 2. Next question, a die is thrown once. Find the probability of getting an even number is the first part of it. So even numbers is going to be 2, 4 and 6 when you throw a die. So that is 3, n of e is 3 and n of s is 6. As we get 1, 2, 3, 4, 5, 6 when you throw a single die. So probability of getting an even number is equal to n of e by n of s. So 3 by 6, further simplifying, 1 by 2. Next is probability of getting a number between 3 and 8. So n of e here is going to be, we need to exclude even 3, so 4, 5 and 6. There is no 8 and all in the list of possible outcomes. So probability of getting a number between 3 and 8 is 3 by 6, that's 1 by 2. Next part of the question is probability of getting even or multiple of 3. So n of e is equal to, even first we'll write 2, 4 and 6. Multiples of 3 is all 3 table, so 3 divisible by 3, so 3, 6 again. It's already been written. So R means we need to include both the combinations. So it's 4 and n of s is 6. So probability of getting an even or multiple of 3 is going to be 4 by 6. Further simplifying, you get 2 by 3. Next, we need to check whether which of the following events are part of probability. So we know the event probability of event lies between 0 and 1. So 3 by 5 is the first part of it, which can be written as 0.6. It lies between that. So yes, it's a part of a probability. Even 2.7 is greater than 1. So no. 43% can be written as 43 by 100, which is 4.43. It lies again between 0 and 1. Yes. It's a part of the probability. And next is negative integer. No. Next one is also no. And the final one is 0.35. Yes, it lies between 0 and 1. So it's a event of a probability. Next, there are 6 identical black balls in a bag. Without looking, a child picks a ball and we need to find of which how many are white and how many are black balls. There are actually no white balls in the sample space itself. So total number of sample space is 6 and the probability of getting white balls is 0 because there are no white balls in the bag. So probability of getting a white ball is 0 by 6. N of e by n of s is 0 by 6, which is 0. Next, probability of getting a black ball. So there are actually 6 black balls. So n of e is 6. And n of s we know is also 6. There are totally 6 balls in the bag. So probability of getting a black ball is equal to 6 by 6 n of e by n of s, which is 1. Next question 14. A single letter is randomly picked from the word probability. Find the probability of getting a vowel. So the possible outcomes is actually the letters of the word probability. So if you count them, it's going to be 11 letters in the word probability. So that is the possible outcomes. To n of s, total sample space is 11, and we need to find the probability of getting a vowels in that. O, A, I 2 times, so it's actually 4. N of E is 4. So probability of getting a vowel in the word probability is 4 by 11. So next question. Ramesh, choose a date at a random in January month for a party. So this is a calendar given in the question for the month of Jan. First we need to find, the total outcomes are 31 days in January. Then n of e is the probability of getting Wednesday. If you count, there are 5 Wednesdays in the month of Jan of this particular calendar. So it's 5 by 31. Probability of getting a Wednesday is 5 by 31. Next, probability of getting a Friday. So again, you see the calendar here, you got 5 days of Friday. So 3rd, 10th, 17th and 24th and 31st are Friday. So that is 5. So probability of getting Friday is again 5 by 31. N of E by N of S is 5 by 31. Next, probability of getting Tuesday or Saturday. Or is there, so we need to include both the combination, Tuesdays as well as Saturday. There are 4 Tuesdays and 4 Saturdays. So we can list them out. N of E is equal to 4th, 7th, 11th, 14th, then 18th, 21st, 25th, and 28th. So if you count them in total, they are 8. They are 8 in number. So probability of getting Tuesday or Saturday is equal to 8 by 31. I hope this is useful. If you find this useful, please do share and subscribe. Thank you.